Hi everyone. A new patient came to the lab today. It's a panel Hisense TV, really, an Android TV from the church that is not really booting up. So the symptoms, the TV is turned on, and the symptoms are remote control. It tries to boot, and then boop, goes kaput. It simply disappears. The LED, I don't know if it can be seen, but the LED is still okay. It's red, and then you try it again, and then it comes up again, and it dies again. So, looking on the internet, I saw a procedure for the firmware update that I tried. Is a similar story. You download the file from their website, plug it into a pen drive, a small pen drive, and plug into the USB port and press a button in a certain sequence, but the firmware doesn't even get checked. It pops up a check-in message and it dies immediately. So the second suspicion, which I already suspected, is naturally the capacitors. Electrolytic capacitors starting to go down, to die. And so let's explore, open up this TV and explore a little bit, to see what could be wrong. Well, just to expedite things, I removed the screws and the cover already. The cover is a regular plastic cover, so you remove a few, probably about 9-10 screws, and it comes right off. And this is the data of the TV. The TV is a 2001 TV, so it's relatively new. But once we open it up, well, first thing that actually caught my attention were the VESA mounts here. There's two tied to the chassis, which are the ones that correspond to the top of the TV. And the two bottom ones, I was trying to find it, and they're actually just tied to the plastic housing. So you guys got to be careful whenever you are holding this TV. This TV stays in vertical, so you always want to be conscious that these two terminals here are weaker. So that's an important bit to consider. But overall, looking at the TV, is a 2001 era. There is a sticker here, and it looks okay. It's not really dirty, but we're gonna take a closer look to see the identification of a few parts that I think will be culprits or actually be causing this problem. So just one zooming as well. This is the so-called the T-cone board that actually transfers the image through these two flat cables to the panel. Due to the nature of the problem, I don't think the T-cone is the problem here, because the image shows perfectly for a few seconds. So I don't think the problem is in here. This big flat cable here connects to the main board. The main board is where the action is actually happening. So this big black part here is the processor, the main processor. Perhaps there's some memory in here and whatnot. Naturally, the connectors in here for the multiple connections. Also, the entire panel is on the side here with the HDMI connections. But what I think is most important is the power supply. One of them, this section in here, part of this section in here, goes to the back panel. Sorry, to the backlight. Sorry. So this is a connection to the backlight, and I suspect this is a connection to the backlight as well. These are high voltage LED panels, but since the image seems stable enough, I don't think that this is necessarily the problem. You have the main power supply. Here comes mains here. There's a lot of filtering in here. Comes mains here, and these two here are the most critical or dangerous parts whenever you're opening such circuit. Why? Because these guys, even after turning it off, I turn it off this TV for a while now, even still these guys hold still quite a voltage in here. And I don't think that there's a bleeder resistor, or maybe there is, but I'm not really seeing it. But you got to be very careful with those. There's still 166 volts stored in these capacitors in here. This will zap you pretty good. So you want to make sure that you actually bleed that using an external resistor of sorts. Just one additional remark. Part of the weird shading. This is not an ideal location for shooting this. But anyways, using a bleeder resistor, just any resistor with a reasonable value and power, actually, you can simply discharge the whole capacitor, and it comes back a little, but it will not come back as high as before. You can also do the same with the other capacitor. You just touch the leads, just making sure that you're not shorting anything. It comes back because there's still a little bit of energy stored around, but you'll never reach those levels of 100 plus volts. This is a good safety measure. Believe me, it'll save you some annoyances. So zooming in on the board, just covering real quick here, as I mentioned before, this is the AC. This entire river of white silk screen is actually tells me that this is the part of the high voltage, meaning whatever is tied to the mains outlet, and everything else is fully isolated from the mains. So basically, through this transformer, through a series of capacitors, everything here is very well done. The board seems very well done. This area here, what we're looking for visually inspecting, are damaged components like charred components or bulging capacitors. They're actually a little bit stuffed. They look stuffed and whatnot, and sometimes charred diodes as well. And there's nothing really in this area that indicates that these two capacitors tend to last a long time. They operate in a very light and lean regime, so they rarely go bad. They do, but they rarely go bad. What actually interests me the most as I peruse here, oh, I was too close, so that's another transformer. This isolates the mains. So what I'm more interested in here are the smaller capacitors that belong to the lower voltages or lower power areas of the circuit. And these capacitors tend to go bad because they are part of switching power supplies that actually really take a toll on them. And I don't know if you can see on the camera. I'll try to get closer a little bit, but these four capacitors, actually two of these four capacitors, the two top capacitors, they are a little bit bulged on the top. Forget about these spots in here. Spots in here could potentially indicate that these capacitors are starting to get leakage and whatnot, but they are also marked from factory. I can tell that every capacitor has a small dot in them, so they're probably marked from factory for some sort of control. But these two top ones, that was the first thing that I saw when I opened this up. They are bulging. They are actually started to be puffy to the top, and then these can cause the types of problems that this TV has. They will make the voltage that supplies parts of the circuit, vital parts, they make the voltage sag under load. So when the TV is starting to boot, then the voltage will sag because the capacitors can't hold their water. So I am almost 100% sure that just replacing those two capacitors at least will make the TV work again. But since I have the others in stock, I can also do this in a bulk. and then solve the problems. Everything else on the board has no real, I can't detect anything. I already took a look. I can't detect anything that is really wrong with it and the lower parts of it. So overall, I think I solved the problem of this TV. So let's get down to the repair. Well, with the board out, you can appreciate a little bit more do a closer inspection. So it's always useful to grab it and remove it and flip it around just to see also if there's any trouble with any parts. I just see a little bit of charred part here. Not charred, but it's natural. It's expected from the processor. The main processor is here, so it heats up a little. There's no other, in a visual inspection, there's no other real trouble or any other charred parts in here. There's a little bit of a residue here and there. It's just for the washing of the board, so there's nothing really concerning to worry about. So flipping around again, I can actually zoom in into the first trouble capacitors that I noticed, and you can tell they're a little bit bulging from their tops, these two guys here, and these are the ones that I actually bought the parts for, so they will be replaced. There is another one here, another capacitor in here. Let me see if it's in focus. Yeah, it is in focus. It's another capacitor that, despite does not show visible signs of damage. I think it's safe to it's safe to at least remove it and test it, just to be sure that this is actually all right. And there are two more capacitors here, these two blue ones. They also do not show signs of bulging, but it's also worth removing those and at least testing those. The big tank capacitors in here, they're rarely affected by they're not the same part of the circuit as the other ones, so usually they are not as damaged as quickly as the other ones. And I also see here, I don't know if it can be seen, there are two small electrolytic capacitors here. They are also part of a circuit that could be easily damaged. So I might see the need to remove them, at least to test them. Usually, as a general statement, testing anything in the circuit is not always a great idea. So my bet are exactly on the top two capacitors, but I'll replace a few others just for fail-safe. So I tested all 5 capacitors, electrolytic capacitors, that I removed from the board on the LCR meter. I'm using a frequency of 120 Hz just because I can compare with any datasheet specifications. But regardless, even at that low frequency, this capacitor, one of the 10 microfarad capacitors, significantly lost its capacity, more than about 80% of its original value. The other 10 microfarad capacitor is the same story. It lost a lot. The 1 microfarad is a little bit less troublesome. It lost about 20% of its value, although its tolerances put it in somewhat the same margin. Because it's the exact same brand and the exact same series as the other 2 10 microfarad capacitors, I'm going to replace this one. The Aishi 105, the 470 microfarad capacitors, they're in excellent shape. They still part of a circuit that has a switching. There's a switcher, which naturally causes a little bit more degradation, but these capacitors are in excellent shape. Given the TV's age, which is 2001, and this is a relatively easy way to find these capacitors and replace them, I think I'll keep the original ones because they are probably still in good shape and they will last for many years. The other ones definitely are going to be replaced. Alright, after soldering, board cleaned with isopropyl and a good brush. And the capacitors, the new capacitors here and here. These other two, I replaced them back. Let's see, moment of truth. And during final assembly, just line up with some of the wires in here. Sorry, some of the screw holes. Check on the various connectors. Some of them are extremely fragile. Gotta be very careful, especially those ones, multi-via. They're extremely fragile, so you gotta always be careful with those. And then you're done. Oh, also tighten the screws on their holes. And more importantly, make sure that there's no metal shards or anything underneath the board that could be shorting something. This is extremely important. I'll finish assembling for the final test. Alright, moment of truth. Let me turn on the cord here. Okay, red LED. Oh, can't be seen, but the red LED at the bottom is on. Let's see, remote control. Yes, yes, yes! It's going, it's booting. It was actually failing pretty spectacularly before. Oh yeah, the camera is a little bit off. But hey, TV is powering on now. So hopefully we'll get we'll get some images in there. I'm gonna do a few more tests on the TV. Oh, there you go. It's booted. Haha, there you go. It booted. Android TV. And probably there's something else going on. But yeah, there you go. It is working. It is working. Let's see a menu of sorts. Input. There you go. Input and everything else. It's working. That's great. Great to see that the TV is actually back on track. All right. So now that the TV is working, return it and off we go to the next project. See you next time.